Okay, I hear the recording in progress. So let me share the screen and get started. Okay, so welcome to our last regular week of classes. Okay, so I'm getting close to finishing. So I'll do some more problems from parametric equation 6.7. Okay, a reminder, our exam is going to be Thursday, the 9th. Usual rules apply. Just like all exams, you show up as usual, turn in this homework. I have to have at least 70% of the homework in order for me to grade your exam. Join the Zoom link, cameras on, true background, all that good stuff. And Friday, so what's happening Friday? Nothing really. I'll just make it an office hour. So you can come or not on Friday. And then all we have is the final exam, which is next Monday. Use the same Zoom link. I'll set it up so you can join at 8:10 to 10:40. Okay, this is set by the school. I cannot change it. So that's going to be the time. Okay, so if you join at a regular time, I'll let you, but that means I have to stop at 10:40. For the final exam, there's no homework to turn in. You don't have to worry about any homework. And for formula sheets, you can have 6 formula sheets for the final exam. So you can have 1 cheat sheet for each of the regular exams. You can have 6 for the final exam. The easiest thing to do is if you still have the old cheat sheets from all the previous tests, just bring them all back in, and you're allowed to add to them too. In case you say, oh, test 3, I forgot to put blah, 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 go ahead and put it in. And you can use that for the final exam. Okay, and final exam, I'm leaning toward 3 questions from every exam. So I'll pick 3 questions from the first test, 3 from the second, 3 from the third, all the way down the line. 3 times 6 is 18. And then maybe I'll pick a couple more problems, or maybe I won't. But that will be the final exam. You get 2.5 hours for the final exam. This Thursday's test is just a regular test, just a regular exam. And there's no homework to turn in for the final exam. You just study for the final, and that's it. Suggestion, I've mentioned this before, Friday, go back and review 2 of the tests. Okay, just, you have the videos already. So I give the videos out the next day, as you know. So Saturday, September 4th, first test. Saturday, the 18th of September, test 2, the videos. Then test 3 would have been what? Saturday, 10/9. Test 4 was Saturday, 11/6. Test 5 was Saturday, 11/20. And well, test 6, you haven't had it yet, but I'll send out the video on Friday, most likely. Okay, so my suggestion is Friday, review test 1 and 2. Saturday, test 3 and 4. Sunday, test 5 and 6. Then you're good to go for the final exam. And then we're done. Okay, and again, I do have office hours during finals week. If you're interested, send me an email. And there we go. Okay. All right, so that being the case, I'll probably finish early Monday, Tuesday, Wednesday. Unless anybody has questions, you can feel free to bring them up. But I may answer some of them because I have my own review questions that previously some students asked for. So here we go. Okay, so getting back to parametric equations. Here's problem 11. X equals e to the t, y equals e to the negative t. Okay. And I noticed just the way exponential functions work, okay, x is always positive, y is always positive. E to anything is always positive. So I'll keep that in the back of my mind. And then I can rewrite y as 1 over e to the t. But what's e to the t? X. So it's y equals 1 over x. So the equation is y equals 1 over x. And you might say, oh yeah, I remember y equals 1 over x looks like that and like that. Yes, but this is not really there because we said both x and y have to be greater than 0. So this portion never gets used. It's over here. Okay, now what about what direction it's going? Is it going up or down? Okay, so I just picked some numbers, like I plugged in 0 and 1. As I plug in 0, I have 1, 1. Okay, so t equals 0 is right there. And once I have this, I just ask myself, do I go that way or I go that way? So just plug in t equals 1. I get e and e to the negative 1, which is 1 over e. That's like 2.73, 0.37. That's over here. So I know, okay, the graph is going this way. All right, so the trick for this one, write this as 1 over e to the t, and then e to the t is x, so 1 over x. And then I said, oh, 1 over x looks like that, but I don't really have this part here because both x and y are positive. And then which direction does it go for positive or increasing time? I just plugged in 0 and 1. Okay, 13, a and b are similar. X equals t, y equals t squared. Well, if I just put x right over there, since t and x are the same, just put it right here, y equals x squared. So, oh yeah, y equals x squared. Looks like that. How do I know it's going this way? I plugged in 0 and I plugged in 1. So do you always plug in 0 and 1? Well, it's the easiest thing to do if you're allowed to plug in 0 and 1. Sometimes you're not allowed to because you might be dividing by 0 or taking a natural log of a negative or something like that. But otherwise, plug in 0 and 1. If I plug in 0, x is 0, and plug in 1, x is 1, so it's going this way. 13b, they just kind of switch these around. X equals t squared, y equals t. So since y and t are the same, just put y right there and have x equals y squared, which I recognize as a parabola opening to the right. Again, you say, how do you know which way it's going? Well, I plug in 0, I'm at the origin. Plug in 1, I'm at 1, 1, so it's going this way. All right, so I know that I'm heading in that direction, so to speak. Okay. All right. So that's it for that one. Show you 13. C. X equals t squared, y equals t to the 4th. For this one, I notice x has to be greater than or equal to 0, y has to be greater than or equal to 0, right? You're only plugging in real numbers. So the thing that comes out is real. You're not going to have any imaginary, there's none of that I stuff. Okay, so now with that background, I can rewrite y as t squared squared, right? That's t to the 4th. Okay, and you say, what do you want to do that for? Because t squared is x. So y equals x squared. So yes, we indeed do have y equals x squared, but this is a little bit tricky. I don't have the entire parabola because of this limitation. X is greater than or equal to 0, y is greater than 0, greater than or equal to 0. There's no way that either x or y could be negative. So I only have this part here. And how do I know it goes this way? Plug in 0, I get 0. Plug in 1, I'm at 1, 1. So increasing t is that way. Okay, and likewise for D, very similar, x equals t to the 4th, y equals t squared. So I can write x equals t to the 4th as t squared squared. And why do I want to do that? Because t squared is now y, so x equals y squared. And you say, well, I just did x equals y squared, yes. But once again, x has to be greater than or equal to 0. Y is also greater than or equal to 0. So this branch here isn't really there. It's only right here. And again, how do I know it's going this way? Plug in 0, 0, 0. Plug in 1, 1, 1. So I know it's going this way. Okay. Okay, 15. A, x is sine of t, y is cosine t. So whenever I see sine and cosine, I try to force there to be a sine squared plus cosine squared equals 1. So I square both sides. Square both sides. Add them up. X squared plus y squared equals sine squared of t plus cosine squared of t. That's equal to 1. That's the usual trick to eliminate the t. When you have a sine and a cosine, force there to be a sine squared plus cosine squared equals 1. Okay, I recognize that as my famous unit circle, but which way is it going? Where does it start? And so on. That's why I have to plug in. Okay, so I plug in 0. Sine of 0 is 0. Cosine of 0 is 1. So it starts up here at 0, 1. Plug in pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. That means I'm at the point 1, 0. So that tells me, okay, it's going this way. So it starts way up at the top and it goes in a clockwise direction. Okay, so this is counter to what we're used to in trig. The standard for trig, of course, was 0 degrees or radians was pointing to the right, and positive was counterclockwise. Why? Because we said so. That's basically it. Okay, but in this case, we're starting way at the top and going around this way. Okay, 15b looks like this. Okay, so again, we're being very forceful in mathematics. It's almost like I'm saying, no, I don't want it that way. I needed to say just cosine, not cosine t plus 1. So I subtract 1 on both sides to make it look like this. Then I square both sides. X squared plus y minus 1 squared. I square this, I square this. That will give me my sine squared of t plus cosine squared of t is equal to 1, right? So it's very forceful. We force the equation to be the way we want it to be. Okay, so that's a circle not centered at the origin, but that shift is 1 up. So the center is 0, 1. So it's a circle. Remember, x squared plus y squared equals 1. That was our famous unit circle. This is still a circle, but it's moved 1 unit up. So there it is. How do I know which direction it goes in? I plug in 0 and pi over 2. And by the way, when you're doing circles and stuff in radians, 0 and pi over 2 are usually preferred than plugging in 1. You say, why don't you plug in 1? Well, I don't know what's the sine of 1 radian, and I don't know what's the cosine of 1 radian. So I'm more comfortable with pi over 2. From 0 to pi over 2 is increasing t. Okay, so plug in 0, sine of 0, 0, cosine of 0 is 1, plus 1 is 2. So I start at 0, 2. Plug in pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0, plus 1 is 1. I move to 1, 1. So it's going this way. Okay, C. X is cosine t plus 1. Y is sine of t. Same thing. I don't want cosine t plus 1. I just want cosine of t. So lose the 1 by subtracting 1 on both sides. X minus 1 equals cosine t. Y equals sine of t. And then square and add. Right? I want cosine squared plus sine squared because then I can change it to 1. So x minus 1 squared is cosine squared t. Plus square this, y squared is sine squared of t. And cosine squared t plus sine squared t is 1. So that allows me to drop out the t's. So x minus 1 squared plus y squared equals 1. That is also a center translated to 1, 0. So my center is 1, 0. Radius is 1. Well, like that. And now how does it go this way? I plug in. Plug in 0. Let's see. Cosine of 0 is 1. 1 plus 1 is 2. Sine of 0 is 0. So it starts at 2, 0. Pi over 2, 1, 1. Sine of pi over 2, 1. Cosine pi over 2 is 0. 0 plus 1 is 1. So it goes this way. Okay. And finally, D. X equals cosine t. Y equals sine t plus 1. So again, get rid of that plus 1. Y minus 1 is sine t. Square. So x squared plus y minus 1 squared. Cosine squared t plus sine squared of t. And that loses the t because that's equal to 1. So I have x squared plus y minus 1 squared equals 1. Center is 0, 1. Goes like that. And same thing, make a little mini table. Plug in 0 and pi over 2. Plug in 0. Cosine of 0 is 1. Sine of 0 is 0 plus 1 is 1. So I start at 1, 1. And pi over 2 evidently gives me 0, 2, which means I'm going this way. So pi over 2, cosine pi over 2 is 0. Sine of pi over 2 is 1. 1 plus 1 is 2. So it's going this way. So it starts here, goes in a counterclockwise direction. Is that right? Okay, 19. Last one. X is t, y is ln t. Well, since x and t are the same, just change that to ln x. Y equals ln x, which I know looks like that quickly, which means x has to be greater than 0. How do I know it goes this way? Well, if you plug in, well, when t increases, x increases. Yeah, just look at this, right? So it has to go like so. I cannot plug in 0, but I can plug in 1. Natural log of 1 is 0. Plug in 2, your x is 2, and so on. So it goes like this. Okay, B, x equals e to the t, y equals t. Okay, I can tell from here already, again, x is greater than 0. Okay, now, since y and t are the same, change that to y. X equals e to the y. How do I solve for y? Take the natural log of both sides. ln, these guys cancel out. Y equals ln x. Same graph. Okay. Same direction if you plug in 1 or 2 or whatever. Or I know, you can look at this and say y, when t increases, y increases. So that means it goes up. Okay, so strangely enough, both of these have the same graph, even though they look kind of different. And then C, x equals t squared, y equals 2 ln t. Now, I can make that 2 climb back up, property of logs, y equals ln t squared. But what's t squared? X. So believe it or not, again, I have y equals natural log of x. Same graph. Okay, and looks like x has to be positive. Yeah, so same thing. And then D even, x equals 1 over t, y equals negative ln t. Sneak in a 1, negative 1 ln t, make it climb back up. So I have ln t to negative 1, which is ln 1 over t. And what's 1 over t? X. So believe it or not, all 4 of these have the same graph. Y equals natural log of x. Okay, that's kind of weird. Okay. So weird, but still doable, hopefully.
Like when I was doing that problem, I instead of finding like the equation first, I just plugged in numbers with a table, and the arrows go a different way though on the last one. That's right though, right?
The arrows go a different way for the last one. Yeah, I didn't graph it. Let's see. When t gets big, x gets smaller. So x gets smaller. Yes, this one will go the other direction. That's correct.
All right. All right. Okay.
Uh-huh. Good observation. Okay, then finally for 17, and then that's pretty much about it. X equals cosine t, y equals sine t. Square and add. X squared plus y squared, cosine squared plus sine squared, 1. Unit circle. Okay, then plug in 0. Cosine of 0 is 1. Sine of 0 is 0. Plug in pi over 2. Cosine pi over 2 is 0. Sine of pi over 2 is 1. So it goes this way. Okay, B. X equals sine t, y equals cosine t. It kind of looks the same. So square and add. X squared plus y squared, sine squared t plus cosine squared t equals 1. It is, again, the unit circle, but let's see where it starts and which direction. So plug in 0, sine of 0 is 0, cosine of 0 is 1. So this graph, even though it's the same as here, it starts up here. This one started over here. This one's up here. And then if I plug in pi over 2, I have sine of pi over 2 is 1, cosine of pi over 2 is 0. It's going to 1, 0. So it's going this way. Okay, so for A and B, even though you have the same graph, you have different starting points in different directions. This one starts at 1, 0, and it goes counterclockwise. Almost, it actually is exactly the same as in trig, the unit circle. This one, same unit circle, but you're starting at the top and it's going clockwise. Okay, now C and D are a little bit weird. Okay, C and D. X is t, y is this. All right, so that tells me right away y is greater than or equal to 0. Even though they don't tell me that for 17, C and D, they don't share with me that information. But you can glean that just from the fact that, square root of a quantity, square root of whatever can't be negative. So y is greater than or equal to 0. Okay, now, since x and t are equal, just put x right there. Y equals radical 1 minus x squared. Square both sides. Add x squared. Unit circle again. But we already said y is greater than or equal to 0. I do not have the bottom half. The bottom half is not there. Let's plug in 0, 0, 1. Plug in 1, 1, 0. It's going this way. So here t is -1, 0, and 1. And that's all I can do. It's not allowed to go outside of that range. Okay, finally D, somewhat similar. X is -t, y equals 1 minus t squared. Okay. Well, if I square both sides of this, I get x squared equals t squared. X squared equals t squared means I can change that to x squared. Well, the algebra is going to be the same as this. So that's x squared plus y squared equals 1. That's not a 1 here in absolute value. That's just a dividing line. Like that. So radical 1 minus x squared equals y, or again, x squared plus y squared equals 1. But let's see how this thing is going. So this time, if I plug in 0, I'm at 0, 1. But if I plug in 1, that's going to be -1, 0. So it's going this way. And again, y has to be greater than or equal to 0. I only have the top part. Okay, so even though I have the same equation in each, this one's the full circle, starting here, going this way. This one's the full circle, starting at the top, going this way. These two, you only have the upper half of the circle because y cannot be negative. Y cannot be negative. And by plugging in values, see, this one's going like that. This one's going the other way. It's going like so. Looks like. And there we go. Okay. All right, that's that. And I'm actually just about done, folks. I do want to go back and show you 6.7 number 8. I know it's an even problem. but to illustrate something. Number 8 should be similar to 9. Okay, so let me show you 8 and then I'll be done. I'll let you ask questions, although I do have a lot of questions I made up on my own. So you can ask, otherwise we can wait until tomorrow and Wednesday. But I'm essentially done, folks. I'll do my own mini review tomorrow and Wednesday. But number 8, x is 3 sine t, y is 4 cosine t. Okay, so remember the trick for this is you want just sine and cosine. If I have just sine and cosine, I can use sine squared plus cosine squared equals 1. So I need to lose the 3. Divide by 3. I need to lose the 4. Divide by 4. So x over 3 is sine of t. Y over 4 is cosine t. So we're very forceful in doing the math. And then square both sides. X over 3 squared, sine squared t. Y over 4 squared, cosine squared t. Add them up. X over 3 squared plus y over 4 squared, sine squared t plus cosine squared t. That's how you get rid of the t. So I just have 1. Okay, they just multiply this out. X squared over 9 plus y squared over 16 equals 1. Hopefully, and we're reviewing for the test, you say, oh yeah, this is an ellipse because there's a plus. If there was a minus, it'd be a hyperbola, right? So b is square root of 9 is 3. Square root of 16 is 4. Watch out, this is not your 3, 4, 5. C is not 5. A is the biggest number. It's a squared equals b squared plus c squared. In other words, don't just automatically say, oh yeah, I know a squared equals b squared plus c squared, 3, 4, automatically 5. No, not this case. Watch out. A is the biggest number. So a squared equals b squared plus c squared. 16 equals 9 plus c squared. C squared is 7. So c is radical 7, 2.6. Okay. So center of the origin. How do I know? It's not parentheses x plus something or y minus something or whatever, right? When it's like this, the center of the origin. Okay, left and right is 3. 1, 2, 3, 1, 2, 3. Negative 3, 0, 3, 0. Endpoints of the minor axis. Up and down is 4. 1, 2, 3, 4. 1, 2, 3, 4. Those are my two vertices. So vertex 1 at 0, 4 and 0, negative 4. The foci are always along the major axis. C is radical 7, it's about 2.6. I go 1, 2, and a little bit more than half. 1, 2, a little bit more than half. But again, when you write it for me, write exact values. So focus 1, 0, radical 7. F2, 0, negative radical 7. Here's what it looks like. But where does it start and which way is it going? Plug in 0 and pi over 2. So how do you know to plug in 0 and pi over 2? There's trig. Okay, now the previous one they didn't have trig, so plug in, 0 and 1 are usually my favorites. But for trig, 1 doesn't help. I don't know what sine of 1, cosine of 1, they're not nice. Pi over 2 is nicer, right? So I plug in 0. Looks like 0, 4. Plug in 0. Get this thing focused here. Sine of 0 is 0, correct. Cosine of 0 is 1. 1 times 4 is 4. So the graph starts at 0, 4, way at the top. And then I just have to ask myself, am I going this way or this way? So I plug in pi over 2. Evidently, it's 3, 0. Pi over 2. Sine of pi over 2 is 1. 3 times 1 is 3. Plug in pi over 2. Cosine of pi over 2 is 0. 4 times 0 is 0. So it's heading toward 3, 0. So that clinches it. It's going this way. So that's what we have. Okay, folks, so I was pretty much done for today. I'll start reviewing for the test tomorrow. But I think I've just about done everything I needed for 6.7. Okay, I did have some questions before from 6.2 and 6.3, so I'll do that starting tomorrow, but I think we've done our quota for the day, so to speak. Okay, so let me stop the share and see if anybody has a question. Let me check the chat. Okay, I don't see anything in the chat. Any questions, please? Otherwise, that's it for today. All right, have a good day, and we'll see everybody next time. Okay, all right, bye, everybody.